Hey guys, welcome to this channel. In this video, we will solve the Leetcode daily question. That is the lowest common ancestor of the deepest level. The question states that given a root of the binary tree, return the lowest common ancestor of its the deepest level. Uh, it is given some points like the node of a tree is a leaf if and only if it is having no children. The depth of the tree is zero. Like root node, the depth will be zero and the children will be d plus one. The here one, two, three, and so on. The lowest common ancestor, and it is another point. Uh, like in this picture, see what is the common ancestor uh, to all the nodes. The common ancestor of all the nodes will be three. So the question asks that like we have to find a node that is common ancestor to the every deepest node. Like in this picture, the deepest nodes are 7 and 4 because it is the like bottommost level present in the tree. So these two are the deepest node, and this is the parent node. So from from this node we are able to reach 7 and the node 4 as well. So it is the deepest level. From 5 also we are able to reach these two nodes, but it is not the deepest. Like the distance between these nodes and this node will be minimum. Here the distance will be the maximum. Now the question like in the 3 points, it is said that the depth of the root node will be 0 and depth of its children will be 1 incremented. Like here 1, here also 1, here 2, here 2, here 2, here 2, and 3 and 3. Like it is the one of the hint which is stated in the question only. Uh, how we are able to solve this question? Like see, if we get the depth of each and every node, it is quite easier to solve the question, right? So how to get the depth? So we will write a function so that it will return the maximum depth in that tree. So here the maximum depth, is 3. So we will reach each and every node, and we will ask to that node, what is the depth of you? Like in 3 in the root node, it says 0, like 0. If it is equal to the maximum depth, like here in this case, the maximum depth is 3. If it is the maximum, then we will return that value. Like starting of this node like 3, what is the depth of this node? Like 0. If it is equal to maximum, no, it's not. Then we will go first left subpart, and then we will go right subpart. We will explore each and every node in the tree so that we can get the answer without failing at edge cases. So that first we will starting at this node. What is the maximum? What is the depth of you? Like in this case, it's 0, and what is the maximum depth? It's 3. So it's not. Then we will go for its left subpart. Here in this case, the children of 3 is 5, left children. So what is the depth of you? The depth of 5 will is here 1, and what is the maximum depth? 3. So here also the condition fails. Then we will go to its left subpart. Here the depth of 6 is 2, and the maximum depth is 3. So it's not the answer. So then we will go to the left subpart. Here there is no value. So if there is no value, then we will return null. So here the children of 6 will be null. Then we will return null to its parent. Like here the parent takes answer as null. At 5 we got left subpart as null, and we have to check the right subpart as well. Here in the right subpart of 5, the right child is 2. Then we will check the depth of the 2. So what is the depth of the 2? Node 2. Here the depth of node 2 is 2. Then what is the maximum depth? 3. So it's not the case. Then we will go for the left subpart. The left subpart is 7. 7. Then we will check the depth of 7. 7. What is your depth? 7 says my depth is 3. Then what is the maximum depth? We will check the maximum depth is 3. Is both are equal? Yes, it's equal. Then we will return 7 value. That is not null value. Uh, at node 2, its parent gives as the value 7. Then it will check for its right subpart. Is there any like value present or not? Then to the control part will move to the 4 and 4. Like what is the depth of here? That 4 says my depth is 3. Then what is the maximum depth? It's 3. So at 4, where I'm able to reach a 4. At 2, I'm able to reach 4 with the maximum depth is with the maximum depth is 3. Then it will return 4 to its parent. At node 2, we are having two values. One is 7 and another is 4. If any node, if any node, from any node we are able to get two values, then that is the lowest common ancestor. Here we will we got two values, right? Then it is the lowest common ancestor. Then this node returns to its value, like return its node, that is true, to its parent. At 5, we got two values. One is null and another is 2. Obviously, we will return not null value, so we will return 2 to its parent. So at root now we are having one value, that is 2, and we will check for its right subpart. The right subpart is 1. 1, what is your depth? The 1 says my depth is 1. Is it equal to maximum depth? No, it's not. Then we will go for its left subpart. The left subpart is 0. What is the depth of the 0? That is 2. And what is the maximum depth? 3. So here also the condition fails. It will go for its the left subpart, that is null value. Then it will go for its right subpart. It again it's null. So if two are null, then it will gives the answer as null value to its parent. Then it will check for its right subpart. The right subpart having the depth as 2, it's not 3. If you go for its left subpart and right subpart, and both are null value. So here we will get null as the answer. We got two values. At 3, we got two values. First one is 2 and second one is null. So obviously, if we have to return the not null value, right? So we will return 2. 2. Here the 2 is our answer. See, here the 2 as our answer. In prefix notation, 2 and 7 and 4. From 2, we are able to raise 7 as 4 as well. For this tree, the answer will be the 2. What if these are not present? What if these two are not present? So the maximum depth will be 2, and here 0, here 1. I got two values and I can reach both as well. So it's also one of the common ancestor. Then the answer will be 3. What we are doing? First we will check the maximum depth, and we will check for its the left subpart and the right subpart as well. And we will check if any value recursively, we will check for its left subpart. This is one is recursion, and we will check for its from any value. If left subpart is null, then we will return right subpart. Like here in this case, the left subpart is null, and we will check for the right subpart, right? And here also, if the here the left subpart is null, then we will return the right subpart. And if it is the right subpart is null, then we will return the left subpart. At any node, if I got two values, two not null values, then it is the common ancestor. Like in this case, I got two null values. Here uh, I got as 7 as well as 4. In this case, in this example, not the previous example, I'm able to get I got 1 as well as 2. Sorry, I got 6 here. I got 2 also here, and these two are the deepest level. These are the deepest leaf nodes, and I will return 5 to its parent. 5 to its parent. In the same case here as well. If any time I got two values, this means that node is the deepest level, is the common ancestor. So if left null, then I will return the right part. If right null, then I will return left part. If both are not null, then I will return the node value. Not null, I will return the node value. Then what will be our base case? See here, if the root is null, if the current traversing node is null, then we will return null value. So let's code this one like in this case the answer is 3. In this case the answer would be the 2, like expected 2. So we will write our answer. So these are the steps. We will follow these only. So the first we have to find the maximum depth. So here in depth, and here the Reynolds L2 row. If root equal to null, greater than -1, else is not required. So the depth of root of left. Also, I have to check for the right depth as well. The APTH depth of root of right. I have to choose the maximum depth, right? So that's why I will check for the maximum of these two. And at every level, the depth will be increased by one. So here the like maximum depth, maximum from the left subpart, maximum from the right subpart, and one incremented here. Like in MX, I will declare one global variable and I will update to the like MX equal to depth. Here I completed this one. So this one is completed. This one also completed. And I have to check for the left value. So what is the base case here? Like here the base case. If it is if the like current exploring node is null, then we will return null. If root equal to null, then return null. What is the other base case? We have solved our null value and we have to check for the if the maximum depth equal to the current depth or not. We'll check here. If mx equal to d, the depth up to that level. If it is equal, then we will return root to its parent. Like here. Like if the maximum depth is here 3, like in this case it's 3, and depth to this node is also 3, then it will return 7 to its parent. That we manage that condition here. Like in this case, what we are doing, we will check for the left subpart and we will check for the right subpart as well. So, trim up tree node left equal to um, like in this one, it's a recursive function, right? So recursively we have to call this one, and then what will be the depth? See here, it's clearly mentioned that the depth will be increased as we are exploring its children. So the D will be incremented by 1 here. Similarly for heads also, in this recursive function, we are able to get sides left and right as well. Then what we have to do is like if left equal to null, then we will return the right. Else if return not here, else return root here. See here the right subpart is null. The right subpart will be null. If the left subpart is null, then we will return the right subpart here. If the left subpart is the null, and we will return right subpart here. Similarly here the both are not null, then we are returning its value, right? If the left value is all in like if the left value is not null and the right value is also not null, then we will returning its root here. Then we have to call this function. So pass root, and we also have to pass the depth of the root. the depth of the root is 0. So let's check for any errors or not. Yeah, it's accepted and submitting. Yeah, accepted like 100% faster than everyone. Okay. If you like this video, please like this video, and if you are having any doubts, then comment in this video. If you are having any alternate approach, then please comment as well, and it will be very helpful to me and as well as some other guys as well.